My computer is located on my left and is a little below the top of my desk. This works out well because it's easy to turn on, and if I have to insert a disk, it's right there within easy reach. On the front side there is a small sliding door that pushes down in order to access additional USB ports, and it also has several types of slots for camera memory cards. This is where the problem comes in. Because the computer color is black and because it is positioned a bit below me, and also because the slots are recessed, it's hard to see where the slots are or which is which, especially at night. So in order to get around this problem, I use a small flashlight to see what I'm doing and to make sure I put the card in the right slot. However, the problem with using this flashlight is that often I have to hunt around to locate it. There's got to be a better solution. Well, I decided I'd add a small light to the computer case instead of using the flashlight. An LED would probably work fine because, first of all, I wouldn't need a lot of light. It also could be mounted right near the slots, and the computer has plenty of power to run the light. It all just seemed like a natural to me. So I went to my local Radio Shack and purchased a twin pack of high brightness white LEDs. I decided I might as well use both of them since there was two in the package. Next, I disconnected my computer and opened it up. I selected one of the free Molex connectors so I could verify the voltage that was available. On computers, the yellow and black leads yield 12 volts direct current, and the red and black leads yield 5 volts. My voltmeter shows that in fact the red and black leads give me the 5 volt reading. Now, after looking at the back of the LED package, I see two important pieces of information. The forward voltage supply for the LED is 3.3 volts, and the forward current is 25 milliamps. So, if the LED only needs 3.3 volts, and if my source is 5 volts, by hooking them together straight away, the LED would immediately burn out. I need to reduce the voltage in order for this to work. I came across this little picture on the internet which explains rather simply what needs to happen. By adding ohms to the circuit, I can use up some of the voltage so that it will deliver the proper range for the LED to handle. All I need to do is add a resistor, but the question is, what size? A little calculating is in order. Perhaps you remember from college or high school days hearing about a German fellow named George Ohms, the man who discovered Ohm's law. His law describes the relationship between voltage, amperage, and resistance. By plugging in the information I already have and by doing this simple math, I find that I need a 68 ohm resistor to solve my problem. Back to Radio Shack. Turns out they don't make resistors in every conceivable value, but they do make one that is 68 ohms, which is just the right size for my project. So after taking off the front of the computer, you can see the area that needs to be lighted. And this is where the LEDs will be mounted. Mounting them here will make this bay permanently unavailable for future equipment, like CD-ROMs and such, but in my case, I can see absolutely no reason to leave it open any longer. Here I had to remove a couple pieces of plastic that were in the way. I noted their removal would not compromise the strength of the cover. One of the LEDs will be mounted here, and the other here. This is the view from the bottom looking up. I put my layout on tape so that I can see where the holes need to be for the LEDs. Since the workspace is small, to use a drill is out of the question. Actually, the space is so small it won't allow a drill bit to fit in. Even a jobber-sized bit is too long. So I took a broken bit that was the right size, heated it up, and melted the two holes through instead of even trying to drill them. It worked out fine. Then a little cleanup and I'm ready to go. Now to work on the LEDs. You notice that one of the wires is shorter than the other. This is because since the LED is a diode, current can only pass through in one direction. That's why it's important to know which way it's going before you solder it up. The long leg is the plus side and the short leg is the minus. With resistors, size is all important and size is easy to determine when they are in the package. However, once outside the package, you must rely on the color coding to find their value. The colors in this case did not show up very well, but they are from the top blue, gray, and black. The color coding uses the primary, secondary, and achromatic colors plus brown to get 10 colors for the 10 digits. It starts with black, which represents 0, then brown for 1. The next colors with their numbers follow the rainbow order, starting with red, while gray is 8 and white is 9. Finish out the code. This is how it is for the first 2 rings. For the third ring, the color represents a multiplier, and using the same color order, black means times 1, brown means times 10, red means times 100, and so forth. The last ring is either gold or silver to represent the percentage of tolerance. Here is a revised schematic drawing of what I am about to do. I suppose it would be a good idea to turn the light on and off, right? So I sifted through my farmer's box and found a micro switch that seems like it would do the job. I'm going to position the switch here just behind the push button, which would be used to open the CD-ROM, if there were one in this bay. I soldered on a couple of new wires and shrunk some tubing over the connections for protection. Next, I mounted the bracket and the switch by mechanical means, but also used hot glue. I'm not a big fan of hot glue because it usually does a poor job of holding, but in this kind of application, it is ideal. Here is a switch looking from the outside in, and here you can see the external button that pushes the push button on the switch. Here you can see the wiring completed with shrink tubing covering even the resistors, and a view of the bottom showing the lights in place. I took a connector off an old floppy drive to make a plug connection for my lights, and here I am making the final hookup. Now the computer is back together and closed up. And voila! Everything seems to have turned out the way I wanted.